Okay, so greetings. Trying to remember where we left off last video, but I think we're going to go from this air gap down to the bottom there with the more narrow air gap, and that once we drop the air gap from here, from an even bigger air gap, the thing got faster and it used less current, which actually it sort of makes sense that you're bringing the coil in, so the magnetic fields are closer together and they can interact with each other more, and it draws less current because as it spins faster, that means while the duty cycle doesn't change, it's still maybe on for 20% or 40% or however much time it's on versus off. The pulse is quicker, and so it's the reactance of the coil acting as a choke, and so that brings the we're again well, today I'm at maybe 70, I'd have to look at it exactly, but like 70 milliamps instead of 75, and I think we were at 1100 something before, and we're at 1031. So, and that's that's really where that sensor is positioned, is most likely. Now I will just, in passing, so I had this thing sitting on the ground there, and I put it on here and fired her up, and it's like I'm losing 250 RPMs and the thing's wobbling all over. It's like, and I'm, what in the heck's going on? So I took the things off, and just as a word of warning to people, these two little things, which I use for the batteries to give connections there, they were sitting on top of one of the magnets there. So of course the thing was unbalanced. So you always got to pay attention. Now the other thing why I haven't dropped things entirely is I was kind of itching and groaning that, oh, how am I going to get a consistent resistive load that I need a coil that can fit under here. And I thought about it, and it's like, well, you dummy, you have a 3D printer, just take an hour and print a new coil form. So that's what I've done here, and I haven't put this in yet, but this is one of the questions I want answered. This will be good. So I'll put this under here and draw off some pickup power that way, and then I'm gonna load the heck out of this thing. I want to slow it down a lot. So maybe a 10 ohm or 100 ohm resistor across here. Then I'll drop it down to there. Now I said everything made sense going from the air core there to here. Now when we go from here to here, if I still see it, maybe it'll do something different this time, then things become very confusing to me, because what happens is your amp draw continues to drop, but now the rotor slows down. And so, if the rotor's going slower, you can't be saying it's all reactance of the coil now. So why is the amp draw dropping as you bring that closer in, and why is it going slower? And it's as though this coil is a load. I'm not entirely certain about that, but I don't know. But I just want to see that it's there again. And then the next question is, so this ballpark, say we're at 1,000 RPMs and it drops to 800 RPMs. If we load the thing, I still think it's going to have a lot more torque with the thing closer in, and that could be important. So that's what I'm going to do here now. On just the very last thing, and then I'll set this up and we'll look at that and then drop these. But the other thing I'll do, I probably won't put it on camera, but I'm going to run it off of this coil because I'm trying to think like 2 steps ahead. Maybe somehow when you bring this big coil down in close, that it's kind of just stepping on its toes in terms of the magnetic field, and that's why it loses rotational speed. So in other words, if you ran it with a smaller coil here and then went in close, does it slow down again? Now if it doesn't, then that means that this coil is so big it's just getting in the way of itself when you get in real close. If it does, then that makes me think that something's feeding back somehow. This thing's causing resistance as well, which is what I think it is, but it's definitely worth looking at. So now I'm gonna get this thing going. We'll see what this thing does. Because we got a new little coil there, and meh. I mean, we're getting 4.6 volts out. I would have liked to have seen like 9 or 10, so need another coil or more winds. But the other thing is that now it's going to be consistent each time. So the last part here is I've got a 10 ohm resistor, so almost like a dead short. So I think you should hear it slow down when I put this across. Come on, give me a second. I'm not sure if you can quite hear it slowing down, but it's slowing down, and I want to see how much it slows down. Okay, well this has slowed it the heck down, which is what I wanted. Let's rebound back up a little bit. I think we were at 1060, so it just about cut it. If it makes it back to 530, I cut it exactly in half. So it cut it a little bit more than in half. So now, when I drop the rotor, we'll look at the speed and we'll look at what happens again. Right now I'm just running it with this thing. It's not doing that bad. I mean, the spike is only 1.3. It's drawing 70 milliamps, maybe even a little less. And it's spinning at, it's taking forever to spin up. It's still climbing, so I'm going to give it some more time. Because, I mean, I can't really load the thing, but I can look at it freewheeling. And if it does slow down, is it going to slow down with this coil too? So I'll give it a little while longer. Okay, so I got rid of the spacers, and for me this is where this now becomes interesting. You could say confusing or you could say interesting. It's both. So the first interesting thing, if we put a tachometer on here, we're doing 957, still climbing a little bit, 958 RPMs. Maybe it would get to 1,000, probably not. No, it seems to be about, that's about where it goes to, is around 957, 958. Now we're just freewheeling. And the second thing that's interesting is we're now drawing 30 milliamps instead of 70, so about half. While freewheeling, the voltage in the cap there is 76.9 instead of 80. So let's just go at this one thing at a time. The two questions here are, one, why did it slow down? And two, why is it drawing less amperage? And you can no longer say that it's the reactance of the coil, because for it to be the reactance of the coil, the pulses would have to be quicker. And because it's slowed down, the pulses are actually longer. So that means that it should have a larger amp draw, but it has the amp draw is like 1/2. And secondly, why has it slowed down? And that's why I'm saying it's like this thing is a load, and perhaps that's the case. Anyways, let's just go out one step at a time. So the first thing is, let's put a 1K across here, and we'll see with this new air gap, does it speed up, does it slow down, does it stay the same, does the amp draw change? What is the amp draw? Let's try and get a good, come on, light. Battery's too low to use a flashlight. The amp draw is, I would call it 30. So, and we put a 1K across there. Certainly didn't go up. Maybe 29, 30. Now, power out was, I want to say like 2.8 when there was a larger air gap. So that's decreased significantly. But then again, we've halved our amp draw, so that might not be a problem. What's happened to the rotational speed? $956.9. I can't remember what I just said. I think it was going to get to 960. I'm going to disconnect this and see if it's changing. Oh, it's slowing down again. So I guess I was saying it would get to 950. So once again, putting a high resistance load, and I should try it with 100. I'll try it with a 100 ohm resistor too. Across there, doesn't increase your amp draw and speeds up the rotor. Now, before I forget to do it, let's put in a pickup coil. And from memory, the thing slowed down to 560. So if it slows down to 560 and we're using only half the amp draw again, that would be good, because we're losing some there, but we're also drawing the amp draw way down. So again, what happens with torque? I've been saying it like a parrot. So I just connected our pickup coil across a 10 ohm resistor. And last time, I want to say it slowed down to 560. So if it slows down to anywhere near there, and we're still drawing half the amps, then that would be good. So let's drop it real quick now. I don't know if we'll see 560 or not. Okay, so this is actually interesting. I've let it settle down here for a while, and I mean, I put my finger on it to slow it down. So it's that's about where it's settled out, is 725 RPMs versus 560. Even though when it's freewheeling, it's faster with the coil further away, but it does have more torque. I knew it. Now it's drawing more amps. Instead of like 25, we're up to like 40, but instead we were going from like, 75 to 120 or something like that, and it was slowing down more. So the smaller air gap for anything related to the pickup coil is better, even though freewheeling it spins slower. Now, what you're losing is that here I'm gonna get rid of the pickup coil. What you're losing is some of the spike voltage. So in other words, what I'm going to do here is, rather than just trying to reset everything, I'm just going to move this thing up and down. So, oops. Okay. Now I'm going to move the coil up. So yeah, I mean it was at 2.7 volts before. Now I'm bringing it back down. So you're losing some from the radiant spike. I'm going to do one last thing and then we'll wrap this video up. I mean, I'm going to keep working on it. And there might be a part 4, because I might try and get the rotor just as close, as small of an air gap as I can without hitting anything. But so far, I mean, the take-home message is that in terms of a pickup coil, the smaller the air gap, the better. But it does hurt what's coming out of your spike, so you'd have to try to figure out which trade-off might be best. So this is the last thing I'll do before I wrap this video up. But you're left with the question of why did the rotor slow down when the coil became closer to it? You'd think it would speed up. And if the rotor didn't speed up, why was the amp draw cut in half? And I don't know. And I also don't know why the power out from the inductive spike went down. So it's all neither here nor there. Now, it did improve the torque, but then again, these things are very low torque machines. So that might not be what you're trying to engineer for. So the last thing I'm going to do is I'm going to put this guy as the drive coil, because as I said, maybe somehow it's like stepping on its toes. And this thing is much smaller, and I did actually jot it down. I can't remember now how fast it was spinning. I want to say like like around 900 RPMs when it had the air gap. So does this one slow down too? Or with the smaller coil, more around the size of the magnet, does it speed up? Okay, not to sound like a complete geek, but for those who may have stuck with me till here, I think this is the most interesting part of the video. So now we got the small coil driving the thing, and this is 26 gauge as opposed to the 22 gauge or whatnot. Again, the amp draw has decreased. I just jotted it down there. So it went from 70 to, I don't know, it's like 35 or something. So it got cut in half again. This is interesting. The power out across the radiant was 1.51, 1.65. So now that's still going up. Whereas we just saw, I didn't jot it down unfortunately, but we just saw this spike was diving on the bigger coil. And lastly, if I can get a, we're doing 944, seems about stable at 944 RPMs. As opposed to 845, so we got another 100 RPMs out. You know, I'm just gonna disconnect the thing here, and it should slow down. Just another one that I don't know why it does it. Well, it's trying to come back a little bit, but it's not at 945, so it slowed down a little. So isn't that interesting? So again, thanks for coming along, and more to talk at you soon. Stay healthy, everyone. Bye-bye.